A12, A13, next A21, A22, A33. So here I am having two rows. This is row 1 and this is row 2. And this is column 1, column 2 and column 3. So the order of the matrix can be written as the product of the rows and columns. The order of a matrix. So how many rows are there? Two rows are there. So 2 into columns. 3 columns are there. So I can write the order of this matrix as 2 cross 3. Many of you would have confusion whether to write a column into row or row into column. So column cross row is wrong. Row cross column. So this is the correct one. So you memorize this number 7. So first you have to go in row side and then you have to come in column side. So this is row and this is column. So number of rows into number of columns. So that is the order of a matrix. Next is row matrix. If a matrix has a single row, then it is called as a row matrix. Example 1, 2, 3. So this has only a single row. Only a single row I am having, but 3 columns are there. This is column 1, column 2, column 3, and this is row 1. So I am having only a single row. That's why it is called as a row matrix. Column, next is column matrix. In column matrix, I will be having only a single column. Example 1, 2, 3. 3 different rows are there, but only one column is there. So this is an example of a column matrix. Square matrix. A matrix in which the number of rows is equal to the number of columns is called as the square matrix. You take this example. You take this previous example. So here I am having a matrix. How many rows are there? Rows 2. And how many columns are there? 3 columns are there. Here the number of rows is not equal to the number of columns. So this is not a square matrix. For a square matrix, the number of rows should be equal to the number of columns. 1, 2, 3, 4. So in this, how many rows I am having? I am having 2 rows and 2 columns. So the number of rows is equal to the number of columns. So it is a square matrix. One, 2, 3, 4, 2, 1, 1, 1, 2. So here the number of rows is 3 and the number of columns is 3. This is also a square matrix. This is called as the diagonal. For a 3 by 3 matrix, these elements are called as the diagonal elements. And for a 2 by 2 matrix, these elements are called as the diagonal elements. See, in general, you can denote the number as A11, A12, A13, A21, A22, A33, sorry, A23, then A31, A32, A33. So the elements in which the row value and the column value is same. See, A, I, J. So this is the general notation. If I write it as A11, then it indicates first row and first column. First row and first column. What is the element present in first row and first column? So in this matrix, what is A11? So here A11 is 1. A12. So first row, second column. So this is your first row, and this is your second column. So first row, second column. What is the element? I am having the number 2. Similarly, you can compare all the values A13, A21, A22, A33, sorry, A23, A31, A32, A33. So in these elements, A11, A22, A33, these 3 elements in which the I value and J value are equal. So these are called as the diagonal elements. If the I and J values are same, then they are called as the diagonal elements. In the gate examination, you will be asked to find the trace of a matrix. Trace of a matrix. So what is this trace? The sum of the elements along the diagonal is called the trace of a matrix. So the trace of a matrix is the sum of diagonal elements. So this is the trace of a matrix. Suppose if I am having a matrix like this, 1, 2, 3, 4. So what are the diagonal elements? 1 is the diagonal element and 4 is the diagonal element. So the trace of matrix A is the sum of diagonal elements. So the sum of diagonal elements is 1 plus 4, so that will be equal to 5. So like this you can find the trace of a 3 by 3 matrix. Next is the null or zero matrix. If all the elements in a matrix are 0, then it is called as a null or zero matrix. Example 0, 0, 0, 0. So this is a null or a zero matrix because all the elements are 0. Next is the diagonal matrix. The general notation for the matrix is A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. So in a square matrix like this, if all the elements are 0, A, I, J is equal to 0, for all I not equal to 0. So what does this mean? I not equal to 0. So this value. In the first value, I is equal to 0. So leave this. In the second, A1, 2. Here I is equal to 1 and J is equal to 2. So if this value, this value, this value, in all this terms, what happens is the I and J values are not equal. So if this values becomes 0, like this, only the diagonal elements will be present and that won't be equal to 0. So that will be having any number like 1, 2 or 1. So in this matrix, all the elements except the diagonal elements are 0. So such a matrix is called as the diagonal matrix. Next is the scalar matrix. See, in the diagonal matrix, if all the diagonal elements are equal, then it is called as a scalar matrix. So in a scalar matrix, all the diagonal elements will be equal. Example, A 1 0 0 0. So you take this as 2 0 0 2. So this is a scalar matrix because the diagonal elements are same. Next is the unit matrix. The unit matrix are, you can even call it as identity matrix. In a unit matrix, all the diagonal elements are 1. So if I'm having a matrix like this, A11, A12, A13, A21, A22, A23, A31, A32, A33. So in this matrix, if the elements A11 is equal to A22 and that is equal to A33, all the three values will be equal to 1. And the remaining values, that is Aij, will be equal to 0 provided I not equal to j. So here I'm having A12. So the value of I is 1 and the value of j is 2. So I value and j value are not equal. So I'm putting it as 0. All the remaining values, that is A11, A22, A33, will be equal to 1. Such type of matrix are called as unit matrix. Next is the upper triangular matrix. From the name itself, you can guess so here the elements A, D and F form the main diagonal. All the values above the leading diagonal will have some numerical values and all the values below the leading diagonal will be 0. So this is called as a upper triangular matrix. It is called as a upper triangular matrix because in the upper part only I am having the values. Similarly, I can have a lower triangular matrix. Lower triangular matrix. In a lower triangular matrix, what happens is only the elements below the leading diagonal will have some values. So this is your leading diagonal ABC. Below this leading diagonal, I will be having numerical values such as some D, E, F. And above this leading diagonal, all the values will be 0. So this is a lower triangular matrix. So in the name itself, you can say upper means in the upper part you will be having some elements. In the lower triangular matrix, what happens is in the lower part, that is the elements below the main diagonal, will be having some integer values or some values, and all the values above the main diagonal will become 0. Transpose of a matrix. The transpose of a matrix is nothing but you are interchanging the rows and columns. You consider a matrix B is 1, 2, 3, 4, 2, 1. So here I am having 2 rows and 3 columns. 2 rows and 3 columns. The transpose of a matrix is denoted, the transpose of a matrix B is denoted by BT. So here I am changing the rows into columns and columns into rows. So here how many rows are there? 2 rows are there and 3 columns are there. So I am row into column. So the number of columns will become the number of rows. How many columns are there? 3 columns are there. So this will become the number of rows. And how many rows are there? 2 rows are there. So here in the transposed matrix, the columns will be 2. So 3 rows and 2 columns. 1, 4, 2, 2, 3, 1. So this is your first column. This is your second column and this is your third column. So the first column has been changed into first row, and the second column has been changed into second row, and the third column has been changed into third row. So this is a transposed matrix. There are few properties for the transpose of a matrix. If you add two matrix A and B and find the transpose of that matrix, so that will be equal to A transpose plus B transpose. You are finding the transpose of a matrix, again once again you are finding the transpose, then it will be equal to the initial matrix A. If you multiply two matrix A and B and find the transpose, that will be equal to the product of the transposed matrix B and A. See, here I have to write it in the reverse order. I am multiplying A, B, and then finding the transpose. So whatever matrix is in the last, so that should come in the first. So here B is in the last, so I am writing it in the first. So B transpose, then A transpose. You should not write like this. A transpose, B transpose. So this is wrong. You have to write it in the reverse order. Next is the symmetric matrix. Symmetric matrix. In symmetric matrix, what happens is the matrix A will be equal to the transpose of a matrix. If you say that the matrix A is equal to the transpose of matrix A, then this matrix A is a symmetric matrix. To take the matrix like this, any matrix 1, 2, 3, 4, 4, 5, so if you take a matrix like this, what is the transpose of this matrix A? You have to interchange the rows into columns. So this is your column 1, this is your column 2, and this is your column 3. So in the transposed matrix, column changes to row. So this column 1 changes to row 1. So 1, 4, 5. What is the second column? 4, 5, 6. So that changes to second row. 4, 5, 6. What is the third column? 5. So this is my third column. 5, 6, 3. So this changes to the third row. 5, 6, 3. So if you compare this matrix A and the transpose matrix AT, you find that both these matrices are same. That is, the matrix A is equal to the transpose of matrix A. If such condition happens, then you can say that matrix A is a symmetric matrix. Next is the skew symmetric matrix. In a skew symmetric matrix, the element in the ith row and jth column is equal to the minus of the element in jth row and ith column. So if it is little bit confusing, you understand with this example. A is equal to 0, 2, 3 minus 2, 0, minus 4 minus 3, 4, 0. And A transpose is equal to 0, 2, 3 minus 2, 0, minus 4, minus 3, 4, 0. So this is A transpose. Now find minus of A transpose. So multiply all the values by minus 1, we will be getting 0, minus 2, minus 3, 2, 0, 4, 3, minus 4, 0. So first matrix A is there. From this matrix A, I am finding the transpose of the matrix A. Then I am finding the minus of the transpose of matrix A. Now if you compare this equation, this two matrix A and the minus of the transpose of matrix A, both are the same. So if A is equal to minus of the transpose of matrix A, then A is called as a skew symmetric matrix. A is called as a skew symmetric matrix. Next is singular matrix. A square matrix. What do you mean by square matrix? A square matrix is a matrix in which the number of rows is equal to the number of columns. A square matrix A is called as a singular matrix if the determinant of the matrix A is equal to 0. If the determinant value is not equal to 0, then A is called as a matrix. Next is the inverse of a matrix. A inverse. So the inverse of matrix is equal to 1 by the determinant of matrix A into adjoint A. So to find the inverse of a matrix, you should know what is adjoint A and what is the determinant of a matrix. So this will be normally asked in 1-mark sums. You will be given a matrix A, and for the matrix A, you will be asked to find what is A inverse. So to find A inverse, you should know what is adjoint matrix, adjoint of A, and the determinant of the matrix A. Take a matrix A, A1, B1, C1, A2, B2, C2, A3, B3, C3. So for this matrix, I can find minor and cofactor. So to find the adjoint A, you should know what is minor, what is cofactor. So you can find the minor cofactor of each of these elements. You can find the minor cofactor of A1, B1, C1. So each of these elements you can find the minor and cofactors. So what is the minor of B1? So this is your B1, and what you have to do is to find the minor of B1, you have to leave this column and this row. So what are the remaining elements? The remaining elements are A2, C2, A3, C3. So this is the minor of B1. Similarly, you can find the minor of any other element. So you take minor of A3. So here I am having A3. So I have to leave this column and this row. The remaining terms are B1, C1, B2, C2. So this is the minor of A3. So if you solve this, you can get this value. How you can solve this? B1, C2. Cross multiply this B1, C2 minus C1, B2. So like this, you can find the minor of different elements. After finding the minor, you have to find the cofactor. Cofactor of A1 or B1. So any elements, you can find the cofactor. So let me write the matrix A. A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is your matrix A. To find the cofactor of any particular element, say I have to find the cofactor of this element B3. So the general formula is cofactor is equal to signed minor. So minor is the determinant that is formed by deleting the particular row and column. Then cofactor. Cofactor is the signed minor. Suppose if I want to find the cofactor of B3. For that, I have to calculate what is the minor of B3. So the minor of B3 is the determinant formed by leaving the column, this column and this row. So I am having A1, C1, A2, C2. So this is your minor. But as per the definition of cofactor, it is signed minor. So here I will be having some sign. So plus or minus. So that depends upon the location of B3. See this B3 is in third, sorry. So this B3 is in third row and the second column. So this B3 is in, so this is your row 1, row 2, row 3, and this is your column 1, column 2 and column 3. So the B3 is in row 3 and column 2. So 3 plus 2 will be having 5. So here I have to put the sign as minus 1 power 5. So how this 5 came? You are adding the row and column number. So row 3, column 2. So 3 plus 2, 5. So minus 1 power 5 will be giving you minus 1 into So if you expand this, I will be getting A1 C2 minus A2 C1. So this is the cofactor of B3. Like this, you can find the cofactor of different elements in a matrix. So now coming back to the inverse of a matrix, the inverse of matrix is equal to the cofactor of A transpose divided by the determinant of A. So to find the inverse of a matrix A, first you should find what is A transpose, then you have to find the cofactor of A transpose matrix. So that will be giving you the numerator part, and in the denominator part just find the determinant of the particular matrix. So if you solve this, you will be getting the inverse of a matrix. Next is matrix addition, subtraction, and multiplication. Matrix addition, if you are having a matrix A and matrix B, then the addition of matrix A and matrix B is possible only if A and B are of the same order. So if we have a matrix like this, A, 1, 2, 2, 3. So this is 2 cross 2, and the matrix B, 1, 2, 1, 1, 3, 2. So here I am having 2 rows and 3 columns. Here the matrix A is 2 cross 2 and matrix B is 2 cross 3. So the order of the matrix A and B are not same. So matrix A, the addition of matrix A and B is not possible. So A plus B is not possible. The addition of matrix A and B is possible only if A and B are of the same order. The matrix addition is commutative, that is A plus B will be equal to B plus A. Also the matrix addition is associative, that is if A plus B is added with the matrix C, this will be giving you A plus B plus C. So this is the associative behavior or associative law. You can write. This is only for addition. For subtraction, neither the commutative nor the associative law holds good. That is, A minus B is not equal to B minus A. So for subtraction, neither the commutative nor the associative law holds good. Next is matrix multiplication. You are having a matrix A and matrix B. the order of matrix A is m into n, m cross n. So what is this m? It is the number of row, and n is the number of column of matrix A. You take another matrix B, the order of the matrix B is A cross B. So what is A? A is the number of row and B is the number of column. The matrix multiplication A cross B. So this is possible only if the number of columns of the first matrix is equal to the number of rows of the second matrix. So if the number of columns of the first matrix and the number of rows of the first matrix are equal, then only the matrix multiplication is possible. The matrix multiplication is associative, that is A B into C is equal to A into BC. So this is associative law. And it also satisfies the distributive law. So what is the distributive law? A into B plus C is equal to AB plus AC. So this is the distributive law. If you have to multiply a matrix by a scalar, A is a matrix and K is some scalar. So for this, you have to multiply the scalar K to each of the elements in the matrix A. If matrix A is A1, B1, C1, D1, then K into the matrix A will give you KA1, KB1, KC1, KD1. So this is the multiplication of a matrix by a scalar.